Chapter 1, Lesson 4 of Pre-Calculus, looking at combining functions algebraically and then determining the domain of the new function. We remember from what we talked about earlier, the domain of the new function is going to be the intersection of the domain of the two original functions. The only thing we have to be careful of is when we're dividing, because the division creates another restriction in the child, or in the new function, which has to be considered because we now have a function in the denominator, so we have to look at that as well. So let's do a couple of examples doing some adding, subtracting, and then we'll do a couple of division examples. So here we have f of x is the square root of x, and g of x is the sine of x, and let's do f plus g of x. So we're going to add these two functions together. Now before we start, because we're going to need the domains at the end to determine the domain of the new function, I like to do the domain of the two functions before I start. So the domain of this function, because it's a radicand, is going to be greater than or equal to 0. So that one's going to look like this in interval notation. And the domain of the sine function is all real numbers, so this would be the domain. So now that we have that taken care of, let's go ahead and do the algebraic operation and add these functions together. F plus g of x. So we take the f function, which is the square root of x, and add it to the g function, which is sine of x. And there's nothing else I can do here as far as simplifying this. There aren't any like terms or anything like that. So this is f plus g of x. Now what is the domain of this new function? And again, it's not as simple as looking at this. We go back and we look for the intersection. And a quick graph picture here, sine of x is all real numbers, right? And then the square root of x is from 0 on up. So where do these two intersect? Well, they intersect from 0 on up. That's where they both overlap. So the domain of this function then is going to be from 0 up to a positive infinity. All right? So let's take a look at another one, but let's subtract these functions. Now again, I mentioned before that we have to be careful when subtracting, because we're subtracting the entire function. And so what I always do is use a parentheses to make sure I distribute that negative sign to both terms of the second function. So again, I want to figure out what the domain is before I start. So this does not have a square root or a denominator, so that's going to be all real numbers. And the same for this one. So this one's going to be pretty easy because the intersection is going to be all real numbers. So let's go ahead and do the function though. F minus g of x. So we take the f function, which is x minus 1, minus, and again, here's where I put this, 3 minus x. Now when I simplify this, we're going to do x minus 1 squared minus 3 plus x. Notice the negative sign gets distributed. The tendency is going to be, and the mistake you're going to make, is if you do subtraction and then you just copy that function, you're going to end up with the wrong value because you notice the sign changes because of the subtraction. Alright, now in a situation like this, we do want to go ahead and multiply this out and simplify it further if we can. So we're going to multiply this. So this is going to be x squared minus 2x plus 1. That's this squared minus 3 plus x. So then we're going to add like terms. So negative 2x and x is negative x. 1 and negative 3 is minus 2. So f minus g of x is this function here. And then the intersection of the two functions is all real numbers, so that would be the domain of this function as well. Alright, so let's do a couple more examples. We're going to use these same two functions, but we're going to do it in two ways. We're going to do f divided by g first, and then we'll do g divided by f and see what the difference is. So f divided by g, again, before we begin, I want to determine the domains of what my functions are here. So x plus 3 on this function needs to be greater than or equal to 0. So x is going to be greater than or equal to negative 3. So in interval notation, that's going to look like this. This function is no radicands and no denominators, so all real numbers. So those would be the two parent functions. We'll need to keep track of those as we do the new function. F divided by g of x then means the f function, x plus 3, over the g function of x squared. Now, we know that the new function is going to have a domain that is the intersection of the original two. So the original two is all real numbers for this function, and then from -3 up for this function. So where do they overlap? Well, they overlap all the way up here from -3. So the intersection would be from here to here. However, if we look at the new function, we'll notice that it has a denominator. And the denominator cannot be 0, so we do have to consider what would make this denominator 0, and that would be the number 0. Now, 0 is part of the overlap, so 0 is right here. So it's part of this domain, but because of this denominator, it's going to be restricted because the new function itself restricts it. So 0 cannot be used in this domain. So I have to again rewrite this from -3, and again just a little picture, from -3 going this way, but I can't use 0. So I can go all the way up to 0, but I can't use it. So that would be from -3 all the way up to 0, and I can't use it. I can then go on the other side of 0 and begin with the first number on the other side of 0 and go all the way up to positive infinity. So when you're dividing functions, you have to look at the intersection, but then you also have to look at the new function and see if it creates some restrictions of its own, because you now have a function in the denominator. Alright, so I'm going to leave that domain here, and then let's take a look at g divided by f and see if it's any different. Okay, so now we want to do the same two functions, but we're going to do g divided by f. Oops, I erased the domains here, but this was -3 up, and then this was from -infinity to positive. Okay, so g divided by f means we're going to take the g function in the numerator this time, which is x squared, and this function, f function, in the denominator. Now again, the intersection is going to be from -3 on up here. But we'll notice that this new function doesn't create any new restrictions. Now upon quick inspection you might think, well no, it's just -3 on up. However, the radicand has to be normally greater than or what? Equal to 0. But this is in the denominator. So it actually cannot be 0 because it's in the denominator. So I have to eliminate the number 0, so x has to be greater than or equal to 3. X has to be greater than -3. Okay, so that means -3 cannot be used, because if it did, that would create 0. So that actually creates a different domain in that the -3 cannot be used. So open circle, or I guess we should use interval notation because that's an open circle up this way. Okay, so we can't use that. Now, is 0 okay in this instance? Well, 0 would make the numerator 0, but that's okay. So actually the number 0 can be used, unlike in this last one where it couldn't be used. So the domain of this function is going to be -3 not included all the way up to positive infinity.